break the lead off that so I don't write on anything. There we go. All right. You guys ready? First one. There's cervical vertebrae. There's 7 of them. Here's how you know if a cervical vertebrae is a cervical vertebrae. It has a hole right here in the transverse process. Now, I didn't even name the transverse process for you, but this is the spinous process, that's the transverse process, this is the centrum of the body, and I'm going to name them again. But every cervical vertebrae, all 7, have a hole in the transverse process. It's called a transverse foramen. All 7 cervical vertebrae have a hole in the transverse process. It's called a transverse foramen, and no other vertebrae have them. So it is fair game for me to put a cervical vertebrae up there for you and say, what type of vertebrae is this? And you'd say cervical because it has a hole in the transverse process. Okay, the first 2, the atlas and axis. This is the atlas, okay? It doesn't have much of a body, a centrum. You can see it has a very tiny centrum. It's C1, and it's called the atlas. In fact, the joint between the occipital bone and the atlas is called the atlanto-occipital joint. So that joint is called the atlanto-atlas occipital joint. So this is the atlas, C1. This is the axis, C2. And let me turn it on its side. It has that process right there. It's called the Dens or the odontoid process. It has 2 names, and I gave you both. Dens or odontoid process. Now let me tell you something. The C1 and C2 articulate like that. Nope, like this. They articulate like that. Shaking your head yes is the skull rocking on the atlas. Shaking your head yes is the atlanto-occipital joint. Shaking your head no, C1 stays tight with this skull, and C1 actually pivots around C2, like that. So shaking your head no is C1 articulating with C2. Shaking your head yes is the skull articulating with C1. Any questions about that? So C1 to C2 is a pivot joint. And today we talk about joints a little bit because they pivot around each other. They pivot around that dens. So this is C1, the atlas. This is C2, the axis. All right, now, the transverse foramen are these holes in the transverse processes of the cervical vertebrae. The vertebral artery runs through that. If you're wondering what runs through it, the vertebral artery runs through those transverse foramen. I don't make you know what runs through it right there. I'm just chit-chatting with you. Transverse foramen. All right. Then we have thoracic vertebrae. And the thoracic vertebrae, you can determine that they are thoracic, and I'll show you how, but I'll just tell you how first. All 12 thoracic vertebrae articulate with a rib. And let me turn the lights on for a second. You can look over here. Not every rib touches the sternum. You can see these 2 ribs on the bottom here don't touch the sternum. But every rib touches the thoracic vertebrae. All 12 of them. All 12 ribs touch the thoracic vertebrae. Because of that, I have these rib facets on my thoracic vertebrae. And this is a rib facet, and believe it or not, right there is a rib facet, because the rib actually touches twice. The rib comes down through here and touches here, then touches there, and then goes out to the sternum. And over here on this transverse process, I have a rib facet here and a rib facet there. So I have rib facets, or smooth surfaces where the ribs touch on my thoracic vertebrae. So I can tell thoracic vertebrae from other vertebrae, because they have rib facets. Now lumbar vertebrae really don't have anything that helps me tell they're lumbar vertebrae except for this. They're large, they don't have rib facets, they don't have transverse foramen. So you're kind of identifying lumbar vertebrae, but what they don't have. They don't have rib facets. There's no ribs touching them. They don't have transverse foramen. And by the way, they are larger than the rest. So if it's large and doesn't have rib facets, you're pretty certain that it's lumbar vertebrae. And there's 5 of them. By the way, that's an approximate number. My son has 6 lumbar vertebrae. And he didn't get it from me. So some people have 6 lumbar vertebrae. By the way, Homo neanderthalensis had 6 lumbar vertebrae. The Neanderthal man. That means my ex-wife and my son are throwbacks. Cavemen. Or women, as the case may be. I'm kidding about that. But some people do have 6 lumbar vertebrae. And if you ever met my son and you looked at him, he has a long torso. And his legs are the same height as me. Our butts line up the same, but he's taller than me because his torso is so much longer. Well, he has an extra lumbar vertebrae. The sacral vertebrae, these are fused. And here it is. This is 5 fused sacral vertebrae. Right here. All right. And then the coccyx is 2 or 3 fused vertebrae. And that's broken. Sorry, that's broken. Let me turn the lights on and show you the coccygeal vertebrae. Thank you. Right here is the coccyx. The one that's up there is broken. So it's 2 or 3 fused vertebrae down here. These are the 2 or 3 fused coccygeal bones called the coccyx. So your tailbone, that's what it is. So the sacrum is 5 fused vertebrae, the coccyx is 2 or 3 fused vertebrae. And everyone's a little bit different. You could be 2, I could be 3, etc. All right? Next. Oh, it says 4 on there. So say 2 to 4 for the coccyx. It's not set. The coccyx is variable. Okay, so individual parts of the vertebrae. I'll give you a thoracic vertebrae until I have to show you something else. We have these, I gotta grab 2 of these. That'll work. These will fit good enough. Yeah, they will. These are both thoracic. We have these articular surfaces on the vertebrae, and this is how the vertebrae sits. So this is superior, and this is inferior, correct? Superior, inferior. This is the superior articular surface right here, and this is the inferior articular surface right here. It's how the vertebrae articulate with each other. Now be careful, because notice that the superior articular surface of the bottom vertebrae articulates with the inferior articular surface of the top vertebrae. Kendall, can you hold that just like that? And I'll go to the board and point that out. So notice that the inferior articular surface of the top vertebrae articulates with the superior articular surface of the bottom vertebrae. Or there's that, let me look at this again. This goes like this. So my thumb is top. Hold it like that again. I think I said it right. I did. This is the top vertebrae. So the inferior articular surface of the top vertebrae articulates with the superior articular surface of the bottom vertebrae. Does that make sense? Thank you. And when you line these up, you'll see that that makes perfect sense. All right, so that's the superior and inferior articular surfaces. Oh, I see I had the word process. These articular surfaces belong on the superior and inferior articular process. So the surfaces are smooth, they articulate with each other, and the process is the part that pops out, the bump. All right, the spinous process is nothing more than this right here. This is the spinous process. The spinous processes line up. You can see that all my spinous processes will line up when these vertebrae stack. So spinous process, spinous process. All right. The transverse processes. These are the transverse processes, transversely. Now they might have rib facets on them if they're thoracic vertebrae. They might have holes in them if they're cervical vertebrae, but these are transverse processes. That's what they are. The body or centrum is just this. That's the body. Okay, lamina and pedicle. Let me tell you how I remember this. Let me point them out and then I'll tell you how I remember this. The part of the bone between the transverse process and the spinous process is called a lamina. This is a lamina. And the part of the bone between the centrum and the transverse process right here is called the pedicle. So this is the pedicle, that's the lamina. Pedicle, lamina. Now here's how I remember it. You guys probably have heard of laminectomies. Laminectomies is when they cut your vertebrae due to a swollen spinal cord or something like that. If your spinal cord is swelling, the most important thing to do is relieve that pressure on the spinal cord because you'll damage nerves. So one thing they do is they do a laminectomy. They just cut the skin on your back and they go in here and cut your bone. However many they need to cut to relieve that swelling. You're going to say, yeah, but you just cut your backbone. Yeah, but you relieve the pressure on the spinal cord. When the inflammation on the spinal cord goes down, that bone will heal. It'll fuse back together. And a lot of time they have this calcium paste that they put on the vertebrae to help it heal quicker. You guys know that they have that calcium paste that helps bones heal quicker? So a laminectomy is cutting right here. That helps me remember that's called a lamina. Because the pedicle is deep in here. You have to look back in here. So the lamina is between the transverse process and the spinous process. The pedicle is between the body and the transverse process. So pedicle, lamina. Okay, the vertebral foramen is right here. That's the vertebral foramen. When you line up all of the vertebral foramen like that, you get the vertebral canal right there. So each individual vertebrae has a vertebral foramen. Here's a vertebral foramen, here's a vertebral foramen. And then when you line them all up, that's the vertebral canal. That's where the spinal cord runs, of course. Now the intervertebral foramina don't exist in an individual vertebrae. It's a notch. This is a notch. This is a notch. Now watch what happens when I put these together. When I put these together, I make an intervertebral foramen, or plural, intervertebral foramina. They actually don't exist in one vertebrae. It only exists when you stack at least two. By the way, that has a fancy name in science. It's called, this is not testable, it's called an emergent property. It's a property that emerges when you become more complex. This intervertebral foramen doesn't exist in a single vertebrae. It exists with two or more vertebrae. So that's an emergent property in biology. That's what we call it. We always look at emergent properties when we have increasing complexity. Not typically in anatomy and physiology, but just in general. All right, any questions about the vertebrae? All right. Now, the ribs. You have 12 ribs, 1 through 12 right here. But notice that 1 through 7 touch the sternum. 1, 2, 3, 4, 5, 6, 7. You're going to say 8, 9, and 10 do as well. Yes. But 1 through 7 touch the sternum with their own cartilage. All right, so these are called vertebral sternal ribs. They go from the vertebrae to the sternum, and they have their own cartilage to the sternum. But notice 8, 9, and 10 share a cartilage. They share one cartilage, and even sometimes they fuse with 7. And this one's actually fusing with 7. So 8, 9, and 10 are not called vertebral sternal ribs. These are called vertebral chondral ribs because they have to share a cartilage to go to the sternum. They don't go to the sternum directly all by themselves. So 1 through 7 are vertebral sternal ribs. 8, 9, and 10 right here are vertebral chondral ribs. And 11 and 12 right here don't go to the sternum at all, so they're called floating ribs. So I have 7 vertebral sternal ribs, 3 vertebral chondral ribs, and 2 floating ribs. Any questions about that? All right.
Those won't be disarticulated. They'll only be
They won't?
They won't be like separate. They'll just be.
I gotta look at my list and see what I have on it. To answer your question, I have to look at my list.
Well, I mean, I think you'll have them separate to say that.
Like this. Get the lights. Now, the blunt end is the end that goes to the sternum. This is the sternal end right here. Here's the sternal end. That's the blunt end. This end is the end that goes to the vertebrae. And it touches the vertebrae twice. That's not big enough. And it touches the vertebrae like this. So you can see, this is the head of the rib. And the head of the rib touches the centrum of the vertebrae. And this tubercle right here touches the articular facet on the transverse process. It touches the vertebrae twice like that. So this is the head right here. This is the neck right here. Right here underneath it is the neck. And then I have the angle. This is the rib angle where it turns. So right here, about where my thumb is, right here is the angle. That's where it turns. It comes up, turns, and goes like that. This is the angle. And the rest of it's the body. Now the articular facets are the smooth areas here, here, and wow, that doesn't fit well. Here's a smooth area. That's an articular facet. It articulates with that articular facet right there. And this is really called a rib tubercle. And that's actually not on your list. I'm surprised. This is called a rib tubercle, and you don't have to know it. But that also helps articulate with the vertebrae. So don't worry about the tubercle. But this smooth surface is called an articular facet. Likewise, this is called an articular facet on the vertebrae. And these ribs touch the vertebrae like that. All right, did I cover everything on the ribs? Head, neck, body, angle, facets, yes. 2 more bones, and then I'll have you cut your videos, and we'll do 2 videos today instead of 1. 2 more bones. Here's one bone. It's called the sternum. This is the sternum, but there's parts of the sternum. This is called the manubrium, and you can see that there is a sutural line right here where they fuse. So this is manubrium. This is the body, and then hanging off the body is called the xiphisternum or the xiphoid process, and it's XIPHI. Some people call this the xiphisternum. Some people call this the xiphoid process. Some of your rectus abdominis muscles hook right there. So the whole thing's the sternum, the top is the manubrium, this is the body, and this is the xiphoid process. Anything else on the sternum? And then the hyoid bone is up in here. Right here is the hyoid bone. It's a floating bone. It floats within tendons and ligaments. But a lot of your tongue muscles hook to it. So your tongue muscles hook to that. And some other things. Yeah, there's a sternohyoid muscle. Some muscles go from the sternum up to the hyoid too. Because think of this. You have to contract a muscle to hold the hyoid steady if you're going to move your tongue around. Because if the hyoid wasn't held steady and you tried to move your tongue around, the hyoid bone was flapping all over the place, it would be hard to control your tongue. So what we do is we have some muscles going from here down to here that hold that hyoid steady. And then we have some muscles from the hyoid to the tongue, and they contract and the tongue moves. All right? Some of the muscles go from the hyoid to the thyroid cartilage of the trachea. Thyrohyoid. There's sternohyoid muscles. There's thyrohyoid muscles. There's a geniohyoid muscle that goes to the tongue. So there's a bunch of muscles on the hyoid bone. And you guys, I think you guys learn muscle actually starting next week or the week after. So we'll talk about some of those muscles to the hyoid bone. All right. Call that the first video of today.